Hey everybody, it's Dr. J, and today we're talking about system and surroundings. Let's talk chemistry. Alright, so essentially we're going to talk about two definitions that are going to be very important. You want to understand what a system is and what a surrounding is, right? And when we're talking about this, we're still talking about thermochemistry. So a system, if I say system, I'm talking about reactants and products. That's what I'm talking about. So that's my chemical reaction we're talking about here, right? That's what we're looking at. And if I say surroundings, think of surroundings as everything else. So if it's not my reactants or products, that's my surroundings. All right. So everything else in the universe is what we call it. So for instance, let's say that our system gives energy, right, to the surroundings. So in this case, if our system gives energy to the surroundings in some type of fashion, right, in this case, our chemical reaction is giving energy to our surroundings. That means that our system, what happened to our system? Our system lost that energy. And because it lost that energy, that means that the system right now is going to be what? Negative. Because it gave away that energy. And because the system gave away energy, we understand what law of conservation of energy, right? Going back to energy being just transferred, right? Nothing's created nor destroyed. So that energy is going where? Somewhere. In that case, that energy is going to the surroundings. So whenever the system is losing energy, the surroundings gain that energy, right? Therefore, making the surrounding energy positive. Now, what does this mean? Well, let's look at an example here. Let's say, right, we got this reaction taking place. We got carbon and oxygen forming carbon dioxide, right? We got our reactants and we have our products. Now, in this instance, this type of reaction is where our system, our reactants, right? Reactants and products, that's our system. So in this case, right, notice the energy. So going back right to unit 3, we understand that reactants are going to have more energy and products are going to have less energy. And that's because, right, when they come together, those valence electrons make that new bond. It's more stable, therefore it has a lower energy, right? If you forgot about that or need some reminding, jump to unit 3, jump back to the previous videos where we talking about all orbitals. Okay, but we understand that reactants is going to have higher energy, products are going to have lower energy. Now, what's taking place here, right, is that those reactants are giving that energy, right? In this case, the energy is flowing to produce those products. Now, what we see here is that our energy level will be negative for this instance. In this case, our energy is going to be what we call released during this reaction. And if your energy is being released, we call this an exothermic process. So essentially, anytime that you're releasing energy or what we're going to talk about, heat, right? Because what we're going to find out is that energy is in fact heat. Stay tuned, right? So exothermic reactions, all right, we call these hot reactions. So this is a hot reaction, everybody, when you combine carbon and oxygen to form carbon dioxide, right? Because that energy is flowing, in this case, out to the surroundings. It's releasing the energy, releasing the heat, so the surroundings is gaining that energy, becoming more positive in this case. So on the other end, let's say that now, instead of my system giving energy to the surroundings, let's say that the surroundings is giving that energy to the system now, right? So now it's the opposite effect, right? To where now, instead of my system being negative, it's going to be positive because it's absorbing or taking in the energy from the surroundings. So when we look on the opposite end, right? So let's say, for instance, let's say that we reverse this reaction, right? Let's say that we decompose carbon dioxide to form carbon and oxygen. What are we going to see here, right? Well, we understand in this case, right? Because if we reverse it, the CO2, right? It's going to form the products in this instance. So in this case, right, we're making our simple elements. So in this case, it's going to have higher energy, right? But instead, the process is just reversed now. So because we got a reverse process, notice what happens, right? Our system gained that energy, therefore our system's going to be positive, which we see over here. Now, this process, anytime instead of releasing energy, you're absorbing energy or gaining energy, we call this endothermic processes. So for the most part, this is a cold reaction when you go from CO2 to carbon and oxygen by itself, right? So it's absorbing the energy or absorbing the heat. All right, and to sum this up, everybody, look at these last 2 points. All right, this sums up everything. Reactants have a higher energy, as we mentioned before, than products. So if your energy of your system is negative, then that means that the energy is flowing out the system and to the surroundings, as we mentioned over here. If your reactants have a lower energy, in this case over here, right, than your products, this means that your energy or your system will be positive. Therefore, your energy will flows into the system from the surroundings, right? So these are 2 important terms you just want to understand, right? Exothermic reactions and endothermic reactions. And it's all based on the flowing of energy, right? If you got an exothermic reaction, you're releasing energy or heat in our chemical reaction. So it's going to be a hot reaction because it's releasing. Or you have an endothermic reaction to where you're absorbing energy or absorbing that heat, and therefore you're going to have a cold reaction.